Well, it's time for us to go charging ahead into the next unit, where we're going to look at functions of several variables and actually analyze them in similar ways to we would have analyzed the function in Calculus 1. So let's go charging ahead. Okay, you got the idea. Many things in the world are functions of more than one variable. For example, the volume or surface area of a cylinder. Think about the surface area of a cylinder would be the area of the two ends, so pi r squared times 2, but then times the area of the wraparound part, right? If it's cut apart, it would make a rectangle, so it would be 2 pi r h, so there's a second variable, r and h. Or its volume is pi r squared h. For the volume of a box is length times width times height, 3 potential variables. So it happens quite a lot in the real world that we have more than one variable. So what is a function, we'll keep it simple at first, of 2 variables? And so if we let D be a set of ordered pairs in r squared, if you will, x, y values. If there's a unique real number, by the way, if there's not a unique real number, if there's more than one, then it's not a function, it's a relation. But if there is a unique real number, f of x, y, that is only one answer, then f is a function of x and y. And the set of values of f is the range of f. So these are definitions that should be familiar to you. Domain, this time it's interesting, instead of the domain being a subset of the real number line, the domain is a subset of the coordinate system with x and y. In other words, a subset of r squared, a subset of the xy plane. And x and y are considered the independent variables, and if z equals f of xy, then z is the dependent variable because it depends on the value of x and y. Here's an example. We're going to find the domain. Actually, let's do more. Range. And sketch. Now, sketch is not something I would ask you to do very much on an exam. Maybe a few, but not. You know, don't spend a whole lot of time learning to draw these. It's helpful, but don't beat yourself up if you can't. So find the domain, range, and sketch. Well, first of all, since this is a function of x and y, and there are no restrictions on x and y because x squared plus y squared is a polynomial in 2 variables, and polynomial functions have all real numbers as their domain. So x could be any real number, y could be any real number, so the domain is the entire xy plane. Now what's the range? Well, the smallest x squared plus y squared could be, since neither x squared nor y squared could be negative, the smallest it could be is 0. The largest it could be is infinity, right? Way above bounds. So we could now say the range of this, the domain, by the way, domain is all real numbers. No, it's not true. It's real numbers cross product with real numbers. So I usually call that r squared, if you'll bear with me on that. R squared, hang on, I gotta make it a superscript. There we go. The domain is r squared. The range, well, that's numbers starting at 0 and going to infinity. And so I need to find a way to print infinity, and I think I might have it somewhere. Here. I'm working on it. There. And of course a round bracket on the infinity because it couldn't possibly be in the set. So it's called a paraboloid if you think about it. When y equals 0, then the trace of this in the xz plane is a parabola, and when x is 0, the trace of it in the yz plane is also a parabola. Is there a trace of this in the xy plane? That's a good question. The answer is no. It's just the point. The point that we call the origin. So here's a picture of it. You can see why it's called a paraboloid. If you look at it from the side, we have cross sections that are parabolas. Notice, if I were to mess with this a little bit, you could see, I think, from a side view, I'll try to straighten it out there a little better. From a side view, you notice that the bottom value is 0, and the highest value, well, unfortunately, it just keeps going up higher and higher. I can't really show you that it keeps going up higher and higher with this picture very well, but I hope you see that. By the way, this is a bizarre way. My software does this in a bizarre way. It draws the z-axis, but it doesn't draw it where we normally would at the origin. It just puts it at the back of the picture. So really it should be coming up out of right here for the way we normally draw a z-axis, but it's just like, I don't know, puts it back there for unknown reasons. But I think you can see the picture pretty well. And that is a paraboloid. We got the domain, the range, and there's the graph. All right.